Hello. Today, in just a tiny corner of math, we're going to be doing a rather interesting problem that my friend or acquaintance, I guess you could say, asked me the other day. Okay, so it says, given the sequence 1, comma 2, comma 4, basically all the powers of 2, going on and on forever, can you can you express every number okay, so, yeah, I don't have the best handwriting, but basically the question was asking if you could add all these numbers together in any combination that you liked, could you express every number? That's okay, every number. And this question, I thought about it for a little while, and at first you might think, well, how would you go about proving it? I mean, it certainly seems like I can, like 1 equals 1, and then 1, or then 2 is just 2, then 3 is equal to 1 plus 2, and 4 is equal to 4, 5 is equal to 4 plus 1, and so on. Right, so it seems as though we can express every number. But let's try a larger number that hopefully you can sort of see what's going on. So let's try 74. Okay. So how would we go about expressing this number without repeats? Sorry, I forgot to say that. Without repeating any of these. Because obviously then you could just add 1 every single time. How would you go about doing that? Well, I would personally start, to ensure no repeats, to add the largest number that I could. So in this case, it's 64, right? That's the largest power of 2 that's closest to it. And then, well, 32 certainly doesn't work. 16, still a bit too high. So, 8 seems good. And now we have an additive total, 72. And then we just add 2. And you'll notice that this process of starting with the largest number and then going on and on until we get closer and closer is actually rather quite similar to another process. And it's how you would convert 74 into base 2. Wondering, well, how do you do that? Well, you see, the way you convert things to bases, if you're not familiar, is, well, you start with 2 to the 0, right? Then plus 2 to the first, plus 2 to the second, plus 2 to the third, 2 to the fourth, and then we're going to need to go out all the way to the sixth for this one. And basically the idea is you put a number here that you multiply by this bottom number. So if I were just to write these down, so you have 64, 32, 16, 8, 4, 2, and 1. So you would write a number up here that you would multiply with the bottom number, and that would show your number. But you also do this in the most efficient way possible, so you would never write a 2 here, for example, because that's just 4, so it's much better just to have written a 1. Okay, so back to how we would express this. So it would be a 1 here, right? And no 32, no 16, and 8, none of this, some of that, none of that. And you'll notice that all the powers of 2 are in this line. So for example, um, 1 is expressible in base 2 as 1, 2 as 10, right? 3 as 100, 4 as 100. So you can see that we have, if you were to add all of these guys, you'll notice that we'll have just a bunch of 1s going on forever. That's the number if we were to add all these, which of course is infinity, but that doesn't matter. And because of this, we can take turns. Let's say we want, let's say we had this number, like 111, okay? Which would require an 8, I believe. Right? We could express every single number that's below, what's this number? 15. So we could express every number below 15 because we'll just say, oh, okay, so I can express every single possible value in base 2, which corresponds to all possible values in base 10 for just these 4. But you can see if I add 16, right? And then, of course, there should be a subscript 2 here indicating it's in base 2. And if we just add another 1, you can see that that would be doable for all of them. Underneath 31. And you see that we could keep going like this, and we could keep expressing all of them. And in case you're wondering as to why we can express all of them, it's common probability, you could say. So this number can either be a 1 or a 0. This number can be a 1 or a 0. This number can be a 1 or a 0. This number can be a 1 or a 0, right? And we have control over that, right? So we can make every single possibility. So if we wanted the number 12, then that's equal to, in base, that's equal to in base 2, certainly not that, that's 2 to 0, yeah, okay, sorry. It would be a 1 here. Right, so we have 8, 8, 0, or 8, 4, 2, 0, 0. So you can see that it would be the same as this set of possibilities. And of course we could do that for every single one because we have complete control. And same with all of them, right? Because we could just simply extend it as far as we want because we have as many numbers in base 2 as we want. So yes, you can actually express every single number if you have all the powers to do.